Welcome to the Math Record. Today I'll be covering the ICTM State 2017 Division A Geometry. I'll be going through every single question from 1 to 20. If you want to look for a specific question, I'll be putting it in the description below in timestamps. Okay, so let's begin. Number 1, determine the number of diagonals that can be drawn in a convex polygon that has 100 sides. So to find that, you could just use the formula, which is just n times n minus 3 divided by 2. So n is equal to 100 because n is your side length. It's your number of side lengths. So plugging it in, 100 times 97 divided by 2, you should get 4850. And that should be an answer for number 1. It's basically just that simple. There's just some formulas you need to know. Right, so that's the formula for the number of diagonals. Number 2, a rectangle is half as wide as long and has a perimeter of x. The numerical area of this rectangle can be written as expression kx squared. Determine the value of k. Express your answer as an integer or common or common improper fraction. So let's kind of draw it. So they said that the width is as long as twice the is half as wide as it is long. So if its long is 2a, right, then it's how wide it is a. Okay, that means its perimeter is 6a, which is equal to our x, and we need to get our area, right? So which is 2a times a, which is 2a squared, and it's in the form kx squared. So what's k? Well, if we square both sides of this is 36a squared is equal to x squared. Since we need a 2a squared, we need to multiply both sides by 18. So that means our 1 over 18 is our k. Okay, so that's answer number 2. Number 3, the circumcenter and a centroid of an isosceles triangle are the same point. You just need to know this. This one's just sometimes. And the reason is because usually isosceles triangle, they and a centroid are circumcenter and a centroid are not the same point. But in an equilateral triangle, a bunch of these points, these special points, the circumcenter, the centroid, and two more that you might have heard of, which is the incenter and the orthocenter, these points all are the same point, and that's why it's sometimes. Because it's if there's sometimes if it's a equilateral triangle, then it's gonna be the some point. If it's not, then it's not going to be, and that's why it's a sometimes. Number 4, rectangular RECT has diagonals that meet at point Z. So let's kind of draw that out. RECT. So they meet at point Z. So that's Z. So RZ, right, is 650. So if half the diagonal is 650, that means the full diagonal is 1300. The and the numerical area of RCT is 739,200. Determine the perimeter. Okay, so using the Pythagorean theorem, right, right triangle, and call this A and call this B. So that means A squared plus B squared is equal to your hypotenuse squared, which is 1300, right? 1300 squared. And we know that our area is A times B, which is equal to 739,200. Now we need to find 2AB, right? 2 times A plus B, right? Because that's our parameter. Well, we need to find AB. So AB, if you kind of think about it, how do we rewrite this in our way with A plus B? So A plus B. So to get those squares, we need a square, right? But that's not the same thing. That is A squared plus B squared minus 2AB. We have our A squared and B squared, but we need to take away 2AB. Well, this one's plus 2AB, sorry. Right? So we have to minus 2AB. So we could take those the AB out. And that should equal to our A plus A squared plus our B squared, right? So we know what A squared plus B squared is. That's 1300. 1300 squared, right? So then we know A plus B squared is equal to 1300 plus there's 2AB. And our AB is this number, so it's just plus 2 times 2, 739,200. That means our A plus B is equal to, use your calculator, 1300 squared plus 2 times 739,200. Take the square root of that, and then you should get a number that's 1780. Okay, so 2 times that to get our perimeter is 3560, which is your answer for number 4. And it's basically just that simple. So you really don't have to solve for the length and the width. All you have to do is just look and manipulate your variables around so they work to find your answer. Number 5, A square with numerical area k is inscribed in a semicircle. A second square with numerical w is inscribed in a full concentric circle, same radius as the semicircle. So that circle has the same radius, okay, but different areas inside for the square. Determine the reduced and simplified ratio k and w, right? So k is the area. Okay, so let's just kind of draw this. So we have a semicircle, so we have a square, oops, right? And the area of this is k. And now we have a full circle. This is not drawn to scale. I'm just trying to draw it like this so it's space, safe space. And they have the same radius, right? So radius here, radius. They have the same radius. And this area is w. So we have to find the ratio from k to w. So if this is your radius, right? If you kind of think about it, this is right in the middle between the square. So if you call this your side length x, and let's put our point for our centers, that means this has to be x over 2. That means the radius of this is, using your Pythagorean theorem, right, is x squared plus x divided by 2, and x divided by 2 is that squared. So that's be x squared plus 1/4 x squared, which is 5/4 x squared, and then take the square root is square root 5 over 2x. So your radius is square root 5 over 2x, which is the same case here, square root 5 over 2x, because it's the same radius. Now, what's the area of this circle, of this of this square? Well, remember this is x times x, right? This is just in half. This one's full length is x. So the k here is x squared. Now we have to find the area here, which is w. So this is for 90 degrees. So since this side length equals this side length, all we have to do is just have base times height, which is just side times side. So 5 square root 2, square root 5 over 2x times square root 5 over 2x divided by 2. That's the area of this one. Now, since there's 4 of them, right? You kind of draw it out. There's 1, 2, 3, 4. That means you multiply by 4 to get the total area. So we can cancel out these 2's with this 4. So this gets 5 over 2 x squared, which is your area for w. That means the ratio from k to w is just coefficient, which is 1, and the coefficient this is 5 over 2. Make it into integers, so that's just 2 to 5. And that's your answer for number 5. I mean, answer for number 5. Sorry about that. Number 6. MAST is a kite, so let's kind of draw that out. Okay, so something like this. I'm not the best artist in the world. And they said that TM is equal to TS, so these two side lengths are the same. And they say TG is 2y minus 2, so 2y minus 2. And GA is a y plus 3. And MG is equal to 2y. And GS is equal to y plus 6. So what you need to know about kites is that the bottom length of those hypotenuse, they have to be the same. So that means 2y is equal to y plus 6. That means y is equal to 6, right? Because this will be 12 and this will also be 12. So if y plus 6, that means that's 12 and that's 10. That's our side length. And this side length would put a 12 here, that's 15. Okay, so if we need to find side length TS, right, this side length, we just use the Pythagorean theorem because that's the right triangle. That's the definition of a kite, which is 10 squared, which is 100, and 12 squared, which is 144. That's 244. Now you square root that, divide square root 244, divide by 4 outside, so that'll be 2, right? Square root of 4 is 2, divide by 4 is 61. And 61 is prime, so your answer is just 2 square root of 61. Okay, and that's your answer for number 6. Number 7. A circle is inscribed within a region that is the solution of x is greater than 2, less than 6, y is greater than 1, and less than 5. Okay, so let's kind of draw a picture. So this is 2, this is 6, this is 1, and that is 5. Right, so our circle is like somewhere right here. That's a bad picture, so something like this. Still a bad picture, but it's okay. So our h is where our x is positioned, which is right between 2 and 6 in the middle. So 2 plus 6 is 8. 8 divided by 2 is 4. So our h is 4. Now our k is the same thing, just be now in the y. So 1 plus 5 is 6. 6 divided by 2 is 3. Now our r is our radius. So our radius, if you go from 2 to 4, that's a difference of 4. So that means our diameter is 4. If a diameter is twice our radius, so 4 divided by 2 is our radius, which is 2. So if our radius is 2, that means r squared, which is radius squared, is just 2 squared. So 2 squared is 4. And then that is your answer for number 7. Pretty simple. Okay, that's just definition of writing the Cartesian version of a circle. Number 8. When the surface area of a sphere is doubled, the volume is increased so that the new surface area is k times the original volume. Determine the value of k. So the surface area of a sphere is 4s squared, where s is your side length. So for you to double it, that means your new side length, right? Let's say this one's your old one, right? For you to double it, that means you had to have 8s squared. That means your new side length had to be square root 2s, right? It has to be square root 2 times your old one, of your new one, right? So old and this one's your new, right? And the reason is because when you square this one, that makes us 2s squared, s old squared, and then we have that formula which is a 4, so multiply by that 4. So then this part plus this part, 4so squared, that's your original area, times 2, that means you double it. So that's why we had to multiply by square root 2s. So that means if we have a volume which is calculated by 4/3 s cubed, right? Now it's cubed. That means it's going to cube this number. So square root 2 cubed is just 2 square root 2. And that's your value of your k. Because that's how much times, that's the time increased. Okay, so that's number 8. Number 9, the perimeter of ABC is 62. Okay, so the perimeter of a triangle ABC is 62. And the length of AB is 4x minus 2. And BC is 5x minus 5. So actually, I'm going to draw the picture. Okay, so let's say A, B, and C. That was a bad picture. Okay. AB is 4x minus 2. BC is 5x minus 5. And AC is 3x plus 9. So they said the perimeter is 62, so add them all up together. So that's 9 and that's 12. Okay. That's minus 7. That's plus 2 equals 62. Right? So minus 2, that's 60. 60 divided by 12 is 5. So x is equal to 5. Okay, so that means this side length is 20, that's 18. That's 15, that's 24. And that's 25, and that's 20. Okay, so find the smallest angle. So the smallest angle is usually with the smallest side. So the smallest side is 18. So the angle right there is 18. I mean, is C. Sorry. Right? The smallest side is 18, so the opposite angle is C. So that's why your answer for number 9 is C. Number 10, equilateral triangle XYZ is inscribed in a circle with diameter 6. So we have a circle, okay, and we have a triangle in there, and it has a diameter 6. So let's just do the radius, which is just 3. And then the tangents to those points form another triangle. So, okay, so it's tangent. Okay, determine the sum of the perimeters of the second triangle and XYZ. So basically, we need to find the sum of the perimeter of this triangle and this triangle. So to do that, let's kind of move this over so I can actually do some math. Okay, so inside, if there's a circle that's going around a triangle, like this one and this triangle, that's called a circumradius. And the circumradius is calculated by having A times B times C or 4 times the area, right? So if you know that equation, so our circumradius is actually 3, right? Because this is 3. And then A times B times C. Since it's an equilateral triangle, let's call this side length A. So that would be, actually, let's call those side length X, right? A, B, C, those are just side lengths of that. And that's why I don't want to call A because you might get confused. So X times X times X is X cubed. And then 4 times the area. The area of an equilateral triangle, you should just memorize this, is x squared squared 3. X squared times square root 3 or 4. So this divided by this equals, cancel out this. And x squared, x cubed, x is on top. So that means x is equal to 3 squared 3. That means the perimeter of this, since one of them is 3 squared 3, that means all three of them, add them together, is 9 squared 3, right? 3 squared 3 times 3. Okay, and that's for circumradius. So now we have something where we have a triangle that's going around a circle, and that is called an inradius. So that radius is still 3. So the formula for inradius is 2 times area divided by perimeter. So our inradius is 3, so 2. Our area is, let's call this one now y. The side length, this really big side length, that's y. So it'll be 2 times y squared, square root 3 divided by 4, divided by our perimeter, which is 3y. So 2 and 4 here, that makes a 2, y, and y squared here, that makes a y. So this simplifies to 3, y square root 3 divided by 6. So that's 3 times 6 divided by square root 3, multiplied by square root 3 on the top and bottom. So this 3 cancels with this 3, makes us 6 square root 3, right, equals your y. Now multiply by 3, because one of the side length is 6 square root 3, so all 3 would now be 18 square root 3. Now add those together to get the sum of the total parameters, which is 27 square root 3, which is your answer for number 10. Number 11. Line L with equation 3x minus 4y minus 4 equals 0 intersect circle O with equation x minus 1 squared plus y plus k squared is equal to 25 in exactly 1 point. So a line and a circle x only intersect at 1 point. Determine the sum of all possible values of k. Okay, so x minus 1 squared plus y. So let's just, since we're given the line, let's substitute that y in. So move the 4y to the other side and then divide by 4. So that'll give us 3/4 x, and then minus 4 divided by 4 is plus 1. And then we set that plus k squared. It's equal to 25. Okay, so this expands out to x squared minus 2x plus 1. And then that's 9 over 16x squared plus 3 over 2x plus 3 over 2kx. Okay, and then plus a 1 plus a 2k and plus k squared. And that should equal to 25. So adding that together, that's 25 over 16x squared. And then, oops, sorry, this one is supposed to be a minus, I believe. Because that's a minus 4 divided by 4. Yeah, that's minus. So this one is supposed to be a minus, and this should be positive. That's fine. This plus 1. This is minus 2k. Okay, so adding that together, so plus 3 over 2k, and then negative 2 plus negative 3 over 2, so that's negative 7 over 2x. And then plus 1 equals 2, minus that 25 equals negative 23. So plus that k squared minus 2k, and then minus that 23 equals 0. Okay, so we have a quadratic now. So how do we get one solution of a quadratic? And that's usually if we have a negative b plus or minus b squared minus 4ac over 2a. So for that to happen, that means the inside of this has to equal 0. So if that equals to 0 squared, 0 is 0, right? So, and then adding or subtracting 0 is basically doing nothing to it. So that means our b squared minus 4ac had to equal 0 for it to be one solution. So b squared, which is 3 over 2. Actually, let's multiply this by 16 first, so we simplify. Some plus multiply by 8, 24k minus 56x. Then that's 16 minus 32k. And then 23 times 16, which is minus 368. And that should be equal to 0. I just don't have room. Okay. So then we have b squared minus 4a and c, which is 16k squared minus 32k minus 368. And that should equal to 0. Okay. So expanding that out, that's 24 times 24, which is 576 k squared. And that is 24 times 56 times 2 minus 2688k And 56 times 56, which is plus 3136. So that's minus 100, so that's minus 1600 k squared plus 3200 k, and then plus 36800. Okay, so subtracting that, that should equal to 0. So subtracting that, we should get, okay, let's kind of move it up so we get a little bit more room to work with this. So let's kind of delete that part. Okay, so that means 0 equals subtracted, that's negative 1024 k squared minus 512k, then plus 39936. So everything seems to be divisible by 512. I'm not sure about the last number, but you just always use your calculator to check. Okay, so divide everything by negative 512. So this gets us 2k squared. Okay, so sorry, this one was positive, right? 320 minus this number is positive. So then this one is minus 1, or minus 1k, which is just minus k. And then 39936 divided by 512 is negative 78. Okay, so this will simplify to 2k, k. So 17 is divisible by 13, 70, yeah, 13. So this one is going to be a plus 6, and this one's minus 13. Because this one's plus 12, minus 13. 12 and negative 13 makes negative 1. Okay, so that means k here is negative 13 over 2, and this one is k equals 6. So I add them together. Oh, sorry, this one is 13 over 2. Sorry about that. I cannot math. K equals negative 6. So this is negative 12 over 2 plus 13 over 2, so that's 1 half. Another way you could know is that this coefficient is 1, right? Ignore the negative and just put the 1 there. So 1, and then divided by whatever this coefficient is should give us your sum, which is 1 divided by 2. That's another way to do it, but I showed you this way so to make sure that's right. Okay, so number 11 is 1 half. Number 12, circle P has diameter AB, and triangle ABC is isosceles with base BC intersecting point at circle D, at point D, where AC is this. Okay, so let's kind of draw that out. So DC is equal to 1 and AC is equal to 4. So if this is 4, that means this is 4. Determine the numerical area of ABC. So what you need to know is that even though I kind of didn't really draw it to scale, I'll draw a little better picture. So we have a point. Okay. So we have a point right here. And the reason I kind of had to do it a little bit more precisely is because if we draw a line from the tip of that triangle to point D, it's gonna be at 90 degrees. And the reason is because you gotta know inscribed angles and lines, and that tells us that this angle, which is 180, right? Half of that would be the angle right here, which is 90. So that tells us that's 90 degrees. That's just the idea of it. So if this is 90 degrees and this is 1, that means this is also 90 degrees, then we use the Pythagorean theorem, right? So 6 hypotenuse squared, which is 16, minus 1 of the side length squared, which is 1 square root, so that's square root 15. So it's square root 15. So the area of a triangle is base times height divided by 2. So it's going to be 1 plus 1, which is 2. 2 times square root 15 divided by 2 is just square root 15. So that's our area. So that's area for number 12. Okay. Number 13. In triangle ABC, AB is, okay, so let's kind of draw this out. A, B, C, where AB is 6 and BC is 9, and D lies on AC, okay, such that ABD and DBC is equal to each other, so these two are the same. And E is the midpoint of BD, okay, so this length is equal to this length because that's the midpoint. The numerical area of ABC is 25. Determine the numerical area of ABE, so this is E. So we have to find this area right here. Okay, so what do you need to know about let's draw that out again. That's E, and that's these two side lengths are the same. What do you need to know about angle bisectors, right? So this angle and this angle, they're the same angle. And if it's a triangle, what you need to know is that this length to this length is proportional to this one to this one. So that tells us that this is going to be 9x and this one's 6x, right? X is some kind of number. It doesn't really matter what it is. It's just that it's going to be in proportion. So that means to get this entire triangle, is just 6x divided by 6x plus 9x, which is 15x, right? And that's why I say it doesn't matter because it's going to cancel out the x. So the proportion of the entire area that's just the 6x is 6x over 15 of that 25. Okay, now that's just this area, right? We need to get this area right here. So to get that area, remember, this was a perpendicular bisector. So we just look at this area. This area is equal to this area because it's a, not perpendicular bisector. It has equal bases. So that means the height is also equal. So it's just going to multiply by a half because they have equal area. So the x cancel with x, this cancel with this to make a 3, 3 cancel with this one to make a 5, so 5 divided by 5 is 5. So the answer for number 13 is 5. And that's just a way to think about it instead of doing all this crazy math. Number 14, a segment of a circle with radius 12 is determined by a 120-degree arc. Determine the area of the segment of the circle. So this is just a really really badly worded question. So that's our center, and we have this section, which is 120. What they're trying to ask is the area of this section. So to get the area of this section, all you have to do is pi radius squared. So pi, our radius is 12 squared, right? And then 120 over 360, right? It's just that section of the circle is divided by 3. So that's the area of that sector of the circle. Now we need to subtract this triangle. So remember, this triangle is 120 degrees. So the area, so the formula for a triangle, area of a triangle, using just one angle, is the two side lengths times the sine of that angle. So it's 12 times 12, which is 12 squared, times sine of 120. And sine of 120 is just square root 3 over 2. Okay? So, and then we divide by 2 to get the final one. So using our calculator, because we approximate to the nearest thousands, 12 times 12 times pi divided by 3, and then we have 12 times 12 times square root 3, and then that's divided by 4. So that area minus that one, we should get 88 point to nearest thousands, so 10's 443. And that's your answer for number 14. Okay. Number 15. In rectangle ABCD, EF is perpendicular to, I mean, yeah, EF is perpendicular to AB, and AE is equal to AD. Okay, so, and AB divided by AD is proportional to EF divided by EB, and that gives us K plus W squared P equals Q. So, let's kind of draw this out. So, if you ever seen this pattern before, it's actually the golden ratio. So, let's kind of work this out. So let's say this is x, right? So this is x, and this is x, and this is x, right? Because they say AE equals AD. And then they told us, and then they said AB divided by AD is equal to EF divided by EB. So let's call this like length, I don't know, 1 or something, right? Actually, let's kind of move this around so it will look a little nicer. So let's call this square 1 because it looks a little nicer. And then let's call that x. Okay. It just makes our calculations a little bit easier, but it's the same thing because we can scale 1 up so it doesn't really matter either way. So how it kind of works is that we're going to have the proportion, which is a, b, which is 1, x plus 1, divided by AD, which is 1. And that's why I said it will make it easier because divide by 1 is easier instead of divide by x. And then we had that length, which is 1, and then that length is just x. So that's EF and that's BD. So we could cross multiply. So that's x squared plus x is equal to 1. So minus that 1 to have minus 1 is equal to 0. So negative b plus or minus, but it's plus because it's negative, so we have to make this one a positive. So b squared, which is 1, because 1 squared is just 1, minus 4ac. So minus 4 times a is 1, times c is negative 1. So that's negative 4 times negative 1 is plus 4. So plus 4, so 1 plus 4 is 5. So this one's plus square 5 over 2a. A is 1, so it's going to be over 2. Okay, so that means k is equal to negative 1, w equals 1, p is equal to 5, and q is equal to 2. So adding them up together, that negative 1, that 1 cancel each other out. So then oh, sorry. And, oops. Actually, no, that's x, right? So we had to find, sorry about that. Not yet, right? Because that's x. So we need to find our ratio, AB divided by AD. So it's either this one or this one. Let's work with this one because it's easier to work with. So adding 1 to it, and then divide by 1, which is dividing by nothing basically. So then plus 1 is all we need to do. So plus 2 over 2, because that's plus 1. So that's 1 plus square root 5 over 2. Sorry about that. Sorry about the previous statement. I kind of misread the question. So then k is 1, w equals 1, p equals 5, and q equals 2. So 1 plus 1 plus 5 plus 2 is equal to 9, right? Because 1, 2, 4, 9. So that's your answer for number 15. Number 16. In a circle with a center C, a minor arc AB has length 8 pi 9. So that's our arc. 8 times pi divided by 9. ACB is equal to 40. So what kind of says is that, let's say, minor arc AB in this circle C, and they say ACB is 40. It's not really drawn to scale. And they said this arc was 8 pi divided by 9, and then determine the radius. So the formula for a area of a circle is pi radius squared. So pi radius squared times, in proportion, 40 out of 360 of the total angle is equal to 8 pi divided by 9. That means our radius is equal to, we could divide the pi out already. So then we could have, right? We could have 8 divided by 9 times 360 divided by 40. And then we could take the square root of that, which is just 2 square root 2. Right? And that should get us for, oops, I messed up the calculations a bit. 8 ninth. Ooh, sorry about that. It's not the area of a circle, it's the circumference. Sorry about that. Which is 2 pi radius times 40 divided by 360 equals 8 pi over 9th, right? Because the circumference of a circle. So 8 divided by 9 times 360 divided by 40, and that is divided by 2, should get us a radius of equal to 4. And that's your answer for number 16. Okay. Number 17. Triangle ABC is a right triangle with BAC as the right triangle. Okay. So let's kind of draw this out. So this is a right triangle. And E is the midpoint of AC. So this is a median. So this is E. So this is equal to this. And DC lies on, D lies on BC such that AD is a perpendicular bisector of at F. Okay, so something like this, even though it doesn't look like a perpendicular bisector, right? So since it's perpendicular bisector, that means this side length is equal to this side length. And this point F, and AD is equal to 4, and BE is equal to 6. So it's a perpendicular bisector, and this is 6, right? So this is 3, and this is 3. Okay? So telling us that, that basically gives us the idea that since this is a perpendicular bisector, that means this side, and this side are all the same. So this is x, and this is x, right? So given by that idea where AD is equal to 4, if you kind of think about it, since these two side lengths are the same and this is a 90-degree angle, that means this is isosceles. That means this is 45 and this is 45. So if this is 45 and this is a right triangle, then cutting this in half in this triangle, this will be a 45. So that tells us that this side length, oops, this side length as this height is 3 also. That means AD, which entire length is 4, that means this side length, this section is 1. Okay. So given us that idea, that means x is equal to 3 square root 2, because that's just a 45, 45, 90 triangle. Okay. So to find the exact perimeter of ABC, we need to find the hypotenuse, which is use the Pythagorean theorem. So x, which is 3 square root 2 squared, plus x, which is 2x, which is 6x squared. I mean 6 square root 2 squared, and take the square root, right? So that's 9, that's 18, that's 36, that's 72, so that's 90. So square root of 90, that's just 3 square root 10. Okay, so 3 square root 10. And that should be this big length. So now this side length is 3 square root 2, and this side length is 6 square root 2. So adding those two together, that's 9 square root 2 plus 3 square root 2 should be your perimeter. So that's your answer for number 17. 9 square root 2, 3 square root 10. Number 18. Determine the length of the altitude of a regular tetrahedron with edges of length 6. So we could just draw like a tetrahedron, right? So something like this. Then we have a line right here, line. Okay, so something like that. So what we're gonna have to do is that we have to draw that center. Actually, I'll just draw a little bit down here. It doesn't really matter how you kind of draw. And then we have to determine the length of the height. So from here to that point, that's our height. And then we draw a line right here to this vertex because that makes a perpendicular. So we're gonna think about this triangle right here. So using that triangle, this is our height. What is this length? So if this is a tetrahedron with side length 6, if you kind of think about it, this is just our gonna be height of a how do I draw this out? So this is, let's say that's 6, right? There's our height, and our point is right here. This is where our centroid is. So to find the centroid, all you need to know if this is a 60 degrees, because it's an equilateral triangle, it's gonna be 6 times square root 3 times square root 3 over 4 is equal to this height. I mean square root 2. So that's 3 square root 3. Okay, now to find this height, what you need to know about centroids is that this length to this length is 2x to x. So to get just this one, you have to multiply by um, 2 over third, because it's 2/3 of that length. So multiply that out, that's 2 square root 3. So that tells us that this side length, this length is 2 square root 3. Okay, and now the last thing we need to get is basically just the length of this side, and that's equilateral, so that's easy, so that's just 6. So that means h squared plus 2 square root 3 squared is equal to 6 squared. So h squared plus, that's 4, that's 12, that's 36. So h squared is equal to 24. So h is equal to 2 square root 6. And that is your answer for number 18. Okay. Number 19. In the diagram, point ABC, okay, just follow this diagram. I'm not going to read it because it's kind of just repeating what's true. So this is tangent, most likely. And they say DC is equal to 12544 over 65. And they say that BC is 224. So find the area of the regions that are inside the circle, but outside the ABC. So that means we have to find this area and add it together. Okay, so then we have to round to the nearest integer. Okay, so first we have to find the radius, right? But to find that radius, we first have to find this length, right? This length right here. So the equation for inscribed angles and lines is x plus, so the entire length, right? The entire length of this times the part outside, 125,446 over 65, is equal to that length squared. That's just a property of inscribed angles and lines. So 224 squared times 65 divided by 12544 equals 260. So that gives us that this entire side length is 260, right? Because we don't need to really find x. We just need to find this is the hypotenuse, right? Because if that's the hypotenuse and that's 260 as our length, right? Let's erase all that work. Then we could just use the Pythagorean theorem to find that diameter. So that's 260 squared minus 224 squared, and then square root should get us that this length is 132. So half of that should be our radius, which is 66. Okay, so now we found our radius. So the area of this circle is pi radius squared, so pi times 66 squared, and then divide by 2 because there's only half of this circle is this area. Now we need to get this circle, right? This section. So this section of the circle, we need to find the angle of this, which is basically just gonna you could just use tangent because remember this is 132. So we have to use inverse tangent. Um, okay, so inverse tangent of 224 divided by 132, which should give you approximately 59 degrees, right? So this is the 59 degrees, and this is also 59, right? Because that's both radius 66, so those two angles are the same. So to get this angle, right, you just have 180 minus that 2 times 59, fit 2 times that angle. So do this on your calculator so you get really precise measurements. So this angle should be around like 61.02-ish, right? And then to get the area of a triangle, which is the angle, as I said before, is gonna be 60. It's gonna be the two side lengths, so 66 times 66 times the sine of that angle divided by 2, and you should get a measurement that's like 1905.2989. I'm just gonna stop right there so we don't have to write them too much. And then the area of a section of that circle is pi radius squared. Okay, so pi times radius squared, which is 60 squared. And then multiply by that angle, right? This angle over 360, right? The proportion of the circle that's that circle of that sector. So that angle, remember, was tangent, inverse tangent of 224 divided by 132 times 2, 180 minus that, which was like 61.02. Yeah. So this times 61.02 divided by 360 should get us an area of 2319.5879. Now you subtract those two areas together, right? So 1905 plus 2989, you should get a area that's roughly 414 as your integer, just for this section, right? Because this area is this one, and this area is this entire thing. So then subtracting it would just give us that area right there. Now what's our area for pi times 66 squared divided by 2? Now add that with 414, and you should get something that rounds up to 7257. Uh, Remember this number was like actually like 414 point like 3 something. So it's gonna be 725 point like 688 etc. ish. So it's gonna round up to 7,257. Okay, that's why you should do it all on your calculator, which I can't really show on the screen. But if you do it on your calculator, you should get the answer. Number 20. The bottom of a regular hexagonal base prism is 2 squared 3. The height of this prism is 10 times the length of one of the bases. Okay, so find the volume. So let's draw the base, which is a hexagon. It's okay. I'm gonna redraw that. That looks bad. Okay, looks somewhat good. So the bottom, it starts from the center and it goes straight down. So that's your bottom. So that's 2 squared 3. Now we have a height, so it goes up, right? So we could draw a hexagon right here, and this height is 10. So to find the volume of this is area of the base times height. So the area of a hexagon is gotta be x squared times square 3 divided by 4 times 6, because this is gonna be a 6 equilateral triangles make a one hexagon. So this simplifies to 3x squared square root 3 divided by 2. So what is x? Well, x is our side length, so we need to find that side length, right? Remember, this is 10x. Sorry about that. 10 times the side length of the base, so this is x. Okay, so let's kind of draw this out. So this one is 2 square root 3. So opposite of a 60 degrees of this side length is x times square root 3 over 2. So that's equal to 2 square root 3. So that means x is equal to 4. Okay. So that means our length of the side length is 4. That means our height is equal to 40. So if you put in 4 in here, that is 4 times 4 squared, which is 16, times, that's 16, times square root 3 over 2, times our height should give us our volume, which is 40. So to divide by this is 8. 8 times 40 is 320, times this 3 is 960, times the square root 3. So our volume for number 20 is 960 square root 3. Okay, and that covers every single question for the ICTM State 2017 geometry. So based on this, you should remember a bunch of formulas, like for inscribed angles and lines, and just some regular shapes, and maybe understand weird concepts like the golden ratio. There's some stuff like silver ratio and bronze ratio. You want to learn that, but I've never seen it used before. Make sure you know how to use circles, right? Properties of circles and properties of triangles, which are the most important to understand for geometry. Well, thanks for watching, and if you have any questions, leave it in the comments below or send me an email.